Within a block of the periodic table of elements, there are a few things that it's important that you understand. So here we have a block of the element hydrogen. Now, if you looked at a periodic table, this block would be up in the top left corner. So first you have the number 1 at the top, which this number varies depending on the element. This is called the atomic number, and it represents the number of protons in an atom. So if you had a hydrogen atom, you'd have 1 proton in there. Now, because an atom is electrically neutral, the number of protons equals the number of electrons. So we know if there's 1 proton, there must also be 1 electron. So although we say this number represents the number of protons, in some ways it also represents the number of electrons. Now, one final note, this is always going to be a whole number, so this would never be 1.5 or 1.43. And this makes sense because you're not going to have half a proton or half an electron in an atom. Next, you have the chemical symbol of the element. So in this case, we have a big H, which stands for hydrogen. Some other chemical symbols are Na for sodium, Ba for barium, and Mg for magnesium. So as you can see, many times the chemical symbol is 2 letters, where the first letter is capitalized and the second letter is lowercase. But sometimes it'll just be 1 letter. Now you can see where the H came from because it's the first letter of hydrogen. And magnesium is easy to figure out because M and G are both in magnesium, and B and A are the first 2 letters of barium. But in some elements, with like sodium, you have N and A, which are letters that aren't even in sodium. And so sometimes it's hard to determine what that chemical symbol stands for. So in many blocks, you will have the full name of the element. So in this case, hydrogen. Now, some periodic tables don't have the full name of the element, but many do. And then finally, you have this last, more complicated number, which is the atomic mass number. And the atomic mass is the number of protons and neutrons in the nucleus of an atom. And so you may be thinking, okay, this must always be a whole number, so how do you have a non-whole number here? That's because this is an average of the isotopes of that element. And an isotope is just a variation of an element. And it's an average, but it's a weighted average, which means the importance of each isotope is factored in to the average. And so this is an average of how many protons and neutrons are generally in a hydrogen atom. So hopefully through this short session, you have a better understanding of the periodic table of elements.